Today is the RF deep dive video into the Avatar HD system from Walksnail. In this video, we're going to be taking a look at the Avatar Stroke Fat Shark goggles, as well as the Avatar VTX on a high-end PC spectrum analyzer to try and show you how this system actually works. That spectrum analyzer that we're using today is the Aaronia Spectran V6, which is a real-time 6 GHz spectrum analyzer, and this is going to allow us to visualize how the RF system works on this system. If you find this video interesting, please do make sure you are a subscriber of the channel. I want to say a massive thank you to Aaronia for helping us to make content like this. And also, if you do find this video interesting, please do check out the links to my Patreon, because I would not be able to make content like this without the support of all of my Patreons. And I just want to say a massive thank you to everyone who does support the channel before we start. Anyway, let's get on with it and let's take a look at how this system actually works, how it compares to DJI, HD0 and some of the others. So we're going to start with the Fat Shark Stroke Avatar goggles. Now, my understanding is these goggles are identical. The RF system is identical between them, so the RF behavior will be as well. There are some things I just want to get out the way before we jump over to the spectrum analyzer, and that is about the behavior of the antennas. I have covered this in other videos. However, I have confirmed that the behavior of this system is a bit different to DJI in the sense of the Avatar system actually only transmits from one antenna and receives from 3. The top right antenna, which is this antenna here, is the transmit antenna, and then the 2 fronts and the top left are receive only. Whenever you're doing any testing with your system, whenever you're using your system on the bench, I strongly advise that you always have an antenna on that top right port. There is the option of moving the antennas around internally if you want to via the UFLs. However, for the purposes of this video, we're going to keep everything the same, and we're going to be measuring the RF from that top right antenna port. So the first thing we're going to take a look at is the power on behavior of the Avatar goggles, because there is some things here you need to be aware of. The Avatar system works completely opposite to the DJI system in the way it actually communicates. What I mean by that is the DJI digital FPV system with the goggles version 1 and version 2 only transmit when they receive a valid signal from an air unit, whether that be the DJI air unit or the Cadex Stroke Runcam Vista Link. The DJI goggles do not transmit at all unless they are connected to the air unit. If the air unit is turned off, the goggles basically do not send out any RF, and you could walk around with them powered on and not cause any problems to other pilots. However, the Avatar goggles work completely opposite. The goggles, once booted up, transmit all of the time on your selected channel, and it is the VTX that only transmits when it receives a valid signal. There is also some other quirks around the power on behavior of these goggles that I want to show you as well. Also, some quirks around the actual power output, which we'll take a look at too. Now, to demonstrate this, what you can see in the background is a full band sweep of the 5.8 gigs FPV band. We are scanning from 5600 to 6 gigs, so this will allow me to show you the whole band at the same time as the system powers on. So what we're going to do is take the Avatar goggles and power them on and wait for them to kick in. It does take somewhere between 10 and 15 seconds for the actual goggles to start transmitting from booting up. It's basically at the point that you see that main screen appear with the OSD elements along the bottom. That is the point the goggles start to transmit. If you look on the screen, what you will see is something interesting has happened. If you were watching closely, you'd have seen that a carrier appeared here, a carrier appeared here, and now it's settled up here. This that you see here is just some low-level local interference because I am so close to the system. You can completely ignore this. The real important things to note is this carrier here, and then the carrier it has settled on here. My observations from the Avatar system is every time it powers up, it jumps between 1 and 2 frequencies before settling on your selected channel. At the moment, you can see the carrier is sitting here on 5662, and that's basically FPV channel 1 on this system, but it did actually briefly transmit on 5737 and 5841, which is basically channel 8, before settling onto the actual channel I've selected. I'll show you this again just so you can see it for a second time. I'm just going to power the goggles off and I'm going to clear the background so you don't have that overhanging, and then we're going to power on again and we're just going to wait and see what it does. We'll see if it does it on the same channels, because it's worth noting that it doesn't always. Ignore this, it's just a local interference. We'll wait for the carrier to kick once. We'll see where it appears. No, up this time it was one up there. Back down to this one here, and then over to here on the actual channel that I have selected. Now, I have done a huge amount of testing on this, and the behavior as I have seen it is it will always hop between 1 and 2 channels. It will hop on one channel, which may not be the same channel every time you boot. It will then either jump to channel 8 and then onto your selected channel, or it will jump straight to the selected channel and then stay there and kick in properly. What it does do though every single time is hop between 1 and 2 times before actually transmitting onto the channel you've selected, and this is worth understanding, especially if you're flying around other pilots, and the very nature of turning these goggles on may cause problems for other pilots in the air simply because of the way it transmits like this. I've hopped over now to a full screen view to allow me to show you some more things with the carrier in a bit more detail. We'll take a look at how large the carrier is, but I also want to show you some interesting behavior with the power output as the system boots as well. So what I'm going to do is now power the goggles on, and we should see the same sort of behavior that we saw on the full band sweep. We are looking at a much smaller section of the FPV band now. I've got it set to channel 1, which is basically somewhere by here, but what you should see is the carrier appear probably somewhere behind my head, and then there it was, it'll hop and then land on the channel that I've selected, which is channel 1 here, and then settle in. Now, if you were watching closely there, you'd have observed some interesting behavior. You've seen the carrier appear behind my head, so I'll just jump to the side so you can see that. That is that large spike there, about the same size as that carrier there. It then hopped onto this channel, which is channel 1, but at a much higher output, and then dropped down to the level you can see there. Now, the goggles are currently set to 25 milliwatts. What you have actually seen is this bit of a quirk in the power output as the system powers on. As I showed just now, it will hop between 1 and 2 channels before settling on your selected channel. In my tests, the output power at that hop isn't maximum, but it's about 25 milliwatts-ish looking at the levels. I can't confirm 100%, but it looks about 25 milliwatts. However, when it lands on your channel, it seems to output maximum power of about 700 milliwatts to 1000, and then drops down to the output that you've set. When I powered these on, it was set to 25 milliwatts. So what it seems to have done is hopped onto the 2 channels that boot at 25 milliwatts, hopped onto the actual channel I've set, which is channel 1 at full output, and then dropped down to the 25 milliwatts. If I show you that again, we'll just power it off. I'll clear the background so you guys can see the same thing again. We'll power it on. Takes about 10 to 15 seconds for that boot process to complete. You'll see, and I'm just going to jump back a little bit, you'll see that carrier kick in, probably somewhere next to my face at a lower level. You'll then see it hop at a higher level on the channel I've selected and then drop down. So there you go, much higher output, and then drop down to the level that I actually have the system set to. Now, there is one other thing you need to understand about this, and this is that the goggles jump to whatever power you have it set. Right there, it jumped to 25 milliwatts because that's what I have it set to. But if you have the goggles set to 700, 1000 or 1200 milliwatts, they will sit at that power level. They do not seem to have a low power mode in the goggles themselves. They will simply jump to the power level that they were last set to. Just to show you this, what I'm going to do now is set the output power on the goggles to a higher level, and I'll do the same power on behavior again and show you how that actually looks. Okay, so the goggles are now set to a much higher output level. They are still set with low power mode turned on. That was the same just now. What we're going to do is power them on, and I will show you that power on behavior again. I'm just going to clear the background, step to the side a little bit just to show you. What we should see is that carrier kick in, and then it jumped to again the same channel, which is channel 1. But note this time what the power level actually settles to. So there's our spike on our first channel. We've now hopped onto our second channel, and then we will give it a second, and now you can see that the carrier has stayed at high power. That is because I have the goggles set at a higher power output, and they've stayed on that higher power output. Again, just to confirm, the goggles do not seem to enter a low power mode at all. The real thing to understand about this behavior is whatever the setting was for your power output that you left the goggles on last with the VTX connected is the power output they will be on. You cannot, though, change that output without powering up the VTX because it is grayed out until the VTX is connected. The goggles will simply power on and go to whatever the setting was that you last used. So I've now set the goggles back to minimum output, 25, and I will just show you that one last time, and then we'll take a closer look at the size of the carrier before moving on to the VTX and showing you the behavior around that. This behavior is something that you need to be aware of because this is going to have a dramatic effect on how you use this system around other people. We can see our main carrier has now kicked in, and we'll just wait for it to settle down. There we go. It has now dropped to our selected power output. Now, the carrier itself from the goggles is basically 5 megs wide. If I just grab it there and there, it's showing up at 4.96. So it's about a 5 megs carrier in total. This is a bit narrower than DJI, but it's also a different style of carrier as well. The goggles carrier on DJI is more like a number of smaller carriers hopping next to each other rather than this larger carrier that we see on the Avatar system. Now, as I mentioned earlier, these systems transmit back and forth, which means the goggles transmit to the VTX and the VTX transmits to the goggles. With the Avatar system, they both always remain on the same channel. So whatever the channel you have set on the goggles is the channel the goggles will transmit to the VTX on, and that is the channel that the VTX transmits back to the goggles on. And we'll see that a bit more as we move on to taking a look at the VTX behavior in a moment. We're now moving over to taking a look at the VTX, and then we'll take a look at the goggles and VTX behavior together. Now, I'm back up at that spectrum sweep looking at the whole FPV band, and what I'm going to do now is just power on the VTX just to demonstrate to you that they do not output any power unless the goggles are turned on. So at the moment, I have the goggles here powered down, and I'm simply going to power on the VTX. It's just kicked in. I'm just watching the LED on the side, and you can see the display here above me. I'm looking, it's just come on solid green, and now it is flashing green. However, as you can see on the band, there is absolutely no RF output at all. I currently have the goggles turned off. There is nothing. It is simply sitting there providing nothing. There's no spikes, there's no hops. The VTX is basically completely inert until it picks up a connection from the goggles. What we're going to do next is take a look at how these communicate when we power them up in a normal scenario. So we'll power up the goggles, and then we'll power up the VTX, and then you'll see the VTX carrier appear over the top of the goggles. Now, currently, both are set to 25 milliwatts, both are set to 25 megabits a second, and that means that it's on the normal bandwidth carrier. We'll drop it onto the 50 or high bandwidth in a minute too. So we'll power up the goggles first of all and allow them to do their boot. What we should see again is that carrier appear maybe on a different channel. This is a much narrower spectrum you're looking at here, so we might not see the hops, but what we will see is that carrier kick in somewhere around here once the goggles have booted up into their more normal operating mode. There we go. Actually, it did appear behind my head, and then it should appear here. It's appearing again at that higher output as I showed earlier, and then it will drop down to the lower output there. What we'll do now is actually connect up our VTX. So what we'll then wait for is that VTX to kick in. Takes about 2 or 3 seconds, maybe up to 5, and then you'll see the kicking there, as you've now seen on the display. So what we now have is that larger carrier of the VTX on the same channel as the smaller carrier of our goggles. Now, the video carrier in this case is about 20 megahertz wide. That says 19.58, about 20 wide in total when in 25 megabits mode, and then it'll be about 40 megabits in 50, and we'll take a look at that in a second. Interesting to note, and I've mentioned this a little bit earlier, that the VTX and the goggles carrier will always be on the same channel. They will always follow each other around. So we're on channel 1 at the moment. If I just change the settings on the goggles up to channel 2, just to show you that. So we'll hop it there, go to channel 2. You'll see that that will hop up. There it goes. Hops up to channel 2. But again, both carriers are followed. If we'll just move that a little bit so you can see that more down the display. We'll get that down this end before we change it again. There we go. We'll move to channel 3. Boom. You can see it there. Channel 4. Boom. Again, they both hop together. You can see that there is a bit of residual on the band when you change channel. I don't really think this is anything major. It's certainly nothing major to worry about. It's just some output on the band as you're actually moving the channels around. You can also see that the output level looks lower. That's simply because of my antenna placement down here. It's nothing to do with the RF output of the system. I've tweaked it now, and you can see that it's showing full output again. So the basics are, with the Avatar system, the goggles and the VTX will always transmit on the same channel. If I now hop it onto 50 megabits mode, so let me just hop out of the settings, and we're going to change over to that higher bandwidth setting. So what we're going to do is change the bit rate to high. Okay, now I've switched it into 50 megabits mode. You'll notice that the carrier looks exactly the same, and that is because the Avatar system has exactly the same behavior now as the DJI system, in the sense that channels 1, 2, and 3 in high bandwidth 50 megabits mode are 50 megabits. Channel 8 public is 25 megabits. Early Avatar firmware actually behaved differently, and all 4 channels were 50, but now in the later versions, channels 1, 2, and 3 are 50, and channel 8, or public, is actually 25. So whilst I've changed the goggles over to 50 megabits mode, we've actually jumped to the public channel, and that's why we're still showing a 20 megahertz wide, 25 megabits carrier. If I now jump to channel 3, which is next to this, and click on that, you'll now see that the carrier has changed, and it's now increased to that much wider carrier as we would expect. If I just take a width on that to show you, that is coming out at about 38 megahertz wide, roughly 40, depending on how you measure it. But you can clearly see that it is that much larger carrier compared to the 25. Let me just clear that. And if I jump back to channel 8, you'll then see it swap, and it's gone down again to that smaller carrier. Overall, this carrier width is pretty much identical to DJI. The 50 megabits and the 25 megabits mode, or the 20 megs and the 40 megs carriers, are basically the same size. There's no real difference here, and you can see that the output changes when we do change the settings. The last thing I just want to walk you through is how the power output changes when you change the settings in the goggles. Now, as I explained earlier, from all of my tests, the Avatar goggles don't appear to have a low power mode. They just go to whatever the power setting is when they power on. However, the VTX does have a low power mode, and that is what is turned on at the moment. The goggles are currently set to the minimum output. However, if I go into the settings, scroll down and start changing the power settings, there is some things I want to show you. I'm going up the power options. I'm going to click save, and you can see that basically nothing has changed on the carrier for the VTX. If I change it there, you can see very little changes. However, do note what does change is the carrier for the goggles. So even though the power output is on low power mode, I can actually change the output of the system for the goggles independently of the VTX, because the goggles simply output what it shows on the display, and that low power mode appears to mean nothing to the goggles at all. If I now just set it to the minimum output and turn that low power, or what is actually known as standby mode to label it correctly, off, and now start changing the settings, you should now start to see the VTX come up with the goggles power. So that is maximum, and I'm changing the settings, and you can start to see the goggles drop down. From that one there to that one there is quite a substantial change, but you can see it. So what is clear is that standby mode, or what I have been calling low power mode, is only for the VTX. The goggles will just output whatever you set the output to, regardless of if the VTX is connected or not, regardless of if that option is turned on or off. Now, just to show you the power on behavior of the Avatar system in 50 megabits mode, I've just powered on the goggles and they've jumped to the selected channel, which is currently channel 3. You can see the goggles are going through their boot up process, and it's now settled, and you can see that channel 3 is there. What we're going to do now is actually power on the VTX to have a look what that behavior actually is. We'll wait for it to connect, and then we'll take a look at what actually happens. Whether it will jump to channel 8 or not, I'm not exactly sure. No, it's simply kicked straight in on channel 3 at full 50 megabits a second mode. So what happens is the VTX will simply follow what the goggles have done already and jump straight onto the channel. There is one last quirk or strange behavior I want to share with you on the Avatar system. As I've shown earlier, when you power on the VTX on its own, it does not output any RF power until it gets a connection from the goggles. They communicate, the RF kicks in, you get an image, you see it on the Spectrum display. However, I'm going to show you a scenario now where I power on a set of goggles that are not bound to that VTX. Currently, it's sitting there flashing green. These goggles are not bound. When I power these goggles up, I do not get an image on the display. I do not have the option to change settings, and the green LED on the VTX remains flashing. However, I want to show you what happens from an RF point of view, because it is something I was not expecting. What I'm going to do is power the goggles on and just place them down and wait for them to kick in. Again, we have this usual 10 to 15 seconds. What I would expect to happen at this point is the goggles transmit, but the VTX not transmit, because they are not bound together. They should not be communicating. However, if we watch on the display, we're about to see something happen, and we have the goggles carrier in the middle, and we have the VTX carrier. At the moment, the VTX LED is flashing green. There is no image in these goggles. They are not bound to that VTX, yet it is outputting RF power on the same channel that the goggles are set to. I'm going to just change the channel on the goggles. Let me just hop in to the menu to show you this. I'm going to change it to channel 2 because it's currently on channel 3. So wait for it. I'm going to press the button. And boom, they have both changed channel again. Yet, these two are not bound together, but they are communicating and they are talking. Now, what the ramifications of this is, I really don't fully know yet. In theory, if you have a VTX that is bound to a different set of goggles and you turn your goggles on, is that VTX going to start transmitting? All I know at this point is this VTX is not bound to these goggles. I don't have another set of goggles to actually bind that VTX to and see what happens. This is something I want to do a lot more testing on, but what is clear is that if the VTX picks up a avatar system, it seems to kick in its RF power output regardless of if it's bound to that system or not. One question I know I'm going to be asked is, how does the avatar system look compared to DJI? So here is your answer. On the screen, we have both systems running at the same time. The DJI system on channel 1, which is this one here, and the avatar system on channel 2, on this one here. Now, as you can see, the main video carrier on both of these systems looks very, very similar. Do not read anything into the power levels, and whilst DJI looks like it's a larger hump, they are not all in the same place on the bench. Everything is just thrown next to each other to get a view. However, what you can see is the main block of the video carrier is the same on both. The real big difference is the uplink carrier from the goggles back to the system. On the avatar system, it's that 5 megs single carrier that you can see there. Whereas on DJI, you have all of these carriers hopping around the main carrier for the video, again on the same channel, but moving around it. If I just show you the difference, if I power down the VTX for the avatar system, the avatar goggles will continue to transmit and you get that single carrier there. And if I now power down my ear unit, for a very short period, you'll be able to just see the goggles carrier on their own. There you go. And you can see them there on the display until it goes off, and they are quite different. Now, as I mentioned earlier with the DJI, the second the carrier from the VTX or the ear unit is gone, so does the goggles output. But I thought I'd put them next to each other just so you could see it. In both 25 and 50, they basically look exactly the same from the video point of view. It's just the goggles carrier up is what's a little bit different. So, as you have seen, there are some fundamental differences between the way the avatar system works and DJI. In front of me here is everything I've been using to actually make the content you've seen in this video. If I hop to the overhead, you can see the bench from above. We've got the RF input to the Spectrum analyzer. You can actually see at this moment in time, there's no antenna on it. That is intentional because it's been done to reduce the output that I'm getting off the VTXs. We've got the Avatar VTX, the Vista, the goggles, the DJI goggles. We've got batteries, power supplies, some more VTXs, air units, a can of Coke to try and keep me going, as well as my phone and other stuff here as well. So it takes a lot of equipment to be able to show you what I have shown you in this video. So there is a huge amount here that we've learned, and there's a lot to think about. From the VTX point of view, everything's pretty straightforward. It only transmits when it has a connection to goggles. It has that standby mode, which works, and the channel of the VTX will always follow the goggles. That side of things is really no issue. Powering on the aircraft around other aircraft users shouldn't give you any problems as long as the goggles are off. But it is worth remembering, if you do power it on next to the goggles, it's going to jump straight to the channels that the goggles are on. The real quirk on this system is this, the goggles, because there are so many strange behaviors going on here. We have the fact that when you power it on, it jumps between multiple frequencies before settling on the channel you've selected. Whilst the initial jumps are at lower power, the jump to the final channel that you've selected, so say you've selected 1, when it lands on 1, it is going to output high RF power for a couple of seconds and then drop to the power level you have set. Regardless of if these are in 25 milliwatt or 1000 milliwatts, they are going to land at high output on the channel you've selected and then drop to whatever the power is set at on the goggles. You cannot stop that. So even setting it at 25 milliwatts isn't going to change that behavior. Furthermore, it's worth remembering that these goggles will output whatever that power level is set to. That power mode that we have on the drone, which is called standby mode, does not appear to affect the goggles. So if the goggles are set to 1200 milliwatts, they're going to output 1200 milliwatts at all times, as far as I can tell. How you actually mitigate these goggles affecting other users, I don't fully know yet. There is no question that powering these on around another user is going to cause problems. You're going to hop on multiple channels, you're going to hop onto the channel you've selected at a high output, and even if you've got it at 25, it's still going to be on a high output for a couple of seconds until it drops down. The only thing you can do is use distance as your friend and power these on well away from other users. There is nothing else you can do to avoid it interfering other than being further away. No matter the setting in the goggles, it is going to turn on and jump across multiple channels, output at high power before dropping to whatever you've set it to. And if you've got it set to a high power level, stay at that level until you change it. That is what you need to take into account when flying with this system around other users. Now, I am super interested in your thoughts in this video. I really hope you have found it interesting. If you have, please do leave a comment and let me know what you think. Give me your thoughts, your questions, and I will try and answer them. I want to say a massive thank you to Aaronia for helping us make this video with the use of the Spectrum analyzer, and a massive thank you to all of my Patreons as well, because I would not have been able to buy these goggles and this system without their support. If you'd like to support us to allow us to keep making content like this in the future, please do check out the links to Patreon as well as Buy Me a Coffee. It's only through your support I'm able to keep making videos like this. Anyway, that's it from me. I hope you found it interesting. Please do make sure you're subscribed, hit the bell as well. Stay safe, and I will speak to you soon.